In this module, we're going to be looking at searching for patterns. Topic 1 will cover quantities and their relationships. Lesson 1 is talking about understanding quantities and their relationships. Make sure that you hit or press the F5 to play the PowerPoint. This will ensure that you are hearing the recording. In this lesson, you will see a yellow arrow. The yellow arrow tells you where to click. Make sure that you scan the QR code right here, or you can press the word attendance and it will go directly to the attendance form to fill out. Look at this problem right here. Emma bought a new video game. The graph shown describes the number of hours Emma spent playing over a period of 7 days. How would you label the axis? What does the highest point on the graph represent with respect to the scenario? What about the lowest point? What does it mean in respect to this scenario? Pause me and think about this. Okay, as you can see right here on the left-hand side of your graph, how would you label the axis? Right here, this on the left-hand side is your time, which is your dependent. It's talking about the number of hours that Emma plays video games. Then your independent is the X horizontal axis, and you're looking at the independent as time, and you're talking about days. So when I'm looking at the highest point of this, the highest point on this graph is at 3 days and 4 hours. So on day 3, Emma spent 4 days playing videos. For the lowest point, you've got 2 of the lowest points. So on day 1, she spent 2 hours playing the games. And on day 6, she spent 2 hours playing video games. So today we're going to be looking at understanding quantities and relationships, identifying the independent quantities for a given scenario. We're going to match a graph with the appropriate scenario. We're going to use appropriate scale for a graph modeling a scenario, and we're going to identify key characteristics of. These are the Tennessee Ready State Standards, and if you want to read through them, you can. The key terms that we're going to be looking at are a dependent quantity and independent quantity. Have you ever planned a party? Think about it. Well, you may have purchased ice, you may have gone grocery shopping, selected music, made food, or even cleaned in preparation. Well, many times these tasks depend upon another being done first. For instance, you wouldn't invite people over to your house before you've gone grocery shopping because you're going to need food to feed these people. Look at the dependent quantity in the first blocks. When we're talking about dependent quantity, we're talking about when one quantity depends upon another. You're looking at the Y column, the vertical axis on a graph, and it's also referred to as the output, or the f of x, which also is the same thing as y. The independent quantity is a quantity that depends on nothing else. It stands alone. It forces the dependent to change. So the quantity the dependent depends upon. The X row is the horizontal row that we're looking at, and the input is the X. So look at the sentence down at the bottom, the blank depends upon the blank. This is what you're going to use. What is it talking about? The blank depends upon the blank. If you look at the right-hand side, you see the independent and dependent. The T-chart right here, the table. The independent is referred to as the input and also the X. And the dependent is talking about the output, which is the Y. So you have the coordinate points 1 and 7 and 8 and 28. Down below you see f of x equals to 3x plus 4. If you put the independent x and the 1 in place of the x right here in the second problem, you see that 3 times 1 plus 4 will give you the answer of 7. The f of x can also refer to as the y. Look at this sentence right here. The cost of shipping a package is based on its weight. Think of it. What are the 2 things that you're talking about right here? I want you to come up with the independent quantity and the dependent quantity. Use the sentence at the bottom. The blank depends upon the blank. And then pause me. Okay, now look at this slide. The cost of shipping a package is based on its weight. The 2 things that we're talking about in this sentence is we're talking about the weight and the cost of shipping. So the independent is the weight. The weight will not change. So it forces the dependent to change. The cost of the shipping is the dependent quantity right here. The cost will depend upon how much the package weighs. So looking at the bottom, you see the cost of the shipping depends upon the weight. In this real world scenario, we're looking at Betsy. Betsy is an office manager for the Gale Enterprise office building. One of her responsibilities is cleaning the office building's 500-gallon aquarium. For cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 20 gallons per minute. What are the two things that we're looking at? I want you to come up with the independent quantity and the dependent quantity right here and pause me and think of these two things. Now I've already gone ahead and answered the what is the independent quantity and dependent quantity. So the two things that we're looking at is time. How long does it take for the water to drain out? And how much water are we draining out? So the independent is time, and the unit of measure that you're measuring, it is in minutes. And the dependent quantity, you're looking at your volume. And how are you measuring your volume? You're measured in gallons. Now look over in the bottom right-hand corner. Think about this. Think D comes before the I in the alphabet. So dependent, which begins with a D, comes before independent in this phrase, gallons per minute. Per, look at the what I have highlighted, gallons per minute. Per is a key word that you're going to look for to help you find the dependent and independent phrase. So remember, D comes before the I, and per is a key word that you're going to look for. Sometimes each can also be a key word. However, not all situations will have the word per or each. And so it is something that you have to think. You will have to try a little harder to come up with the answers. But gallons per minute, D comes before the I, and so gallons is your dependent and minute is your independent. Look at this scenario with Betsy again. I have included the graph for this scenario. This graph is linear. It is a straight line, and we are starting with 500 gallons, and it is going out at 20 gallons per minute. So it is a constant draining of 20 gallons per minute. So that is why it's linear, because it is constant. The rate that is going out, the rate of change is 20 gallons. So you start with 500 gallons, and then you end up eventually with no water in the tank. The independence down on the x-axis down at the bottom, you're looking at time, and the unit of measurement is in minutes. Then on the y-axis, the vertical axis, you're looking at your dependent, and this says it's water in gallons, or you can put volume in gallons. But we're looking at the unit of measurement as gallons. Look at this real world scenario. You have your eye on an upgraded smartwatch. However, you're currently broke. Your brother will provide the funding as long as you pay him back with the interest. He tells you that you only need to pay him $1 in interest initially, and then the interest will double each week after that. You consider his offer and wonder, if this is this really a good deal? So you're going to identify the independent and dependent quantities in this scenario. Put me on pause and think about it. So now we are back looking at this real world scenario. We're looking at two things. The independent quantity is your time. You're looking at it in weeks, and your dependent quantity is you're looking at the interest, and it's measured by dollars. And I have a graph that's already that you can see right here. This is called an exponential growth graph because it is increasing from left to right. Now think about this. The first week, all you have to do is pay back $1. The second week, remember, you're doubling every single week. So the second week, 1 plus 1 is 2. Okay, double that, you get 4. Double that, you get 8. Double that is 16, then 32, 64, and you will keep doubling it every week. So eventually you're going to be paying back a lot of money for this. So do the figuring yourself. Just double it every week. Start with $1. Now in this real world scenario, Jessie is the drum major for the Oakland High School Marching Band. For the finale of the halftime performance, Jessie tosses her baton in the air so that it reaches a maximum height of 25 feet. This gives her 3 seconds to twirl around twice and catch the baton when it comes down. What are the independent and dependent quantities in this scenario? Put me on pause and think about it. Now, you see for Jessie, you're looking for the key word per, and I don't see it in this one, or nor do I see the word each. So what are the two things you're looking at? Well, you're looking at your time and you're looking at how high does she throw the baton up into the air. So the independent quantity is time, your unit of measure is seconds, which is your independent quantity. Your dependent quantity, which is your y-axis, is the height or the distance that she throws the baton up in the air, and your unit of measurement is feet. I've already shown you the graph to the right, and this is a quadratic graph. It is a U-shape, a parabola. We will be looking at those later. Look at this real world scenario. Mikey loves skiing. He just hates the ski lift. To make matters worse, the ski lift has been acting up today. Mike is using the GPS on his phone to track the ski lift's progress as it travels up the mountain. It moves at a steady rate of 500 feet per minute until it stops suddenly. Mikey calls his friends to tell them that he is stuck. They talk on the phone for 11 minutes until finally the ski lift begins moving again. So find the dependent and independent quantities in this. And remember, look for the key words, see if you can find any. Now, in this real world scenario with Mikey, you do see the key word per. So look in front of it is the word feet, which is your dependent quantity, and then the independent is minute. And so the independent quantity, you're talking about time, and the unit of measure is in minutes. Your dependent quantity is distance, and the unit of measure is looking at feet. I have put the graph right here so that you can see, and I have labeled the x-axis and the y-axis with the independent and dependent quantities. And this right here is the graph that would describe this real world scenario. There's a worksheet that I have attached to use with this activity, or you can write it down on your own sheet of paper. What you're going to do is identify and match the independent and dependent quantities. So pause me and see if you can match them. On this slide, I have gone ahead and matched the first set for you. So you're looking at the dependent quantity, how far you can drive, and the independent quantity, the amount of gas that you have in your vehicle. How far can you drive depends upon the amount of gas that you have in your vehicle. So this is the first one, match the others, and pause me. Now on this slide, I have gone ahead and matched the independent and dependent quantity. So see if you can figure out which one is the dependent and which one is the independent quantity. So pause me and see if your answers are the same as mine. Here are the answers to the activity you just completed. Look at number 1. The winner of a football game depends upon who scores more points. Number 2. How much you make depends upon the hours you work. Number 3. How much air conditioning you use depends upon the temperature. Number 4. Your grade depends upon the amount of assignment you turn in. Number 5. Your cell phone bill depends upon the number of minutes used. Number 6. Cost of a speeding ticket depends upon how many kilometers you went over the speed limit. Number 7. Time it takes to drive somewhere depends upon how fast you drive. And number 8. How far you can drive depends upon the amount of gas you have. Look at this real world scenario. Waverly is driving to visit her uncle who lives 467 miles away from her home. She travels an average of 74 miles per hour. I want you to identify the dependent and independent quantities right here. Put me on pause and look for them. Here are the answers that you were looking for Waverly. They have the key phrase in this scenario, the word per, so miles per minute. So miles is your dependent quantity, and that is talking about distance, and it's being measured in miles. And then your independent quantity is looking at hours, and you're measuring it by hours. In this real world scenario, Brinley draws different sized spheres in a notebook. She knows there's a relationship between the surface area of the sphere and the length of its diameter. What is the dependent quantity in this situation? So in this scenario, find the dependent quantity and put me on pause and find it. Here you will see the dependent quantity for Brinley is the volume of the surface area. The volume of the surface area depends upon the length of its diameter. So the dependent quantity is the surface area of the sphere, and the independent quantity is the length of its diameter. In this real world scenario, Mimi knows there's a relationship between the number of trucks she washes and the time it takes her to wash those trucks. Identify the independent quantity and the dependent quantity in this problem situation. Pause me while you look for it and identify it. Here are the answers that you're looking for. There is not the word per in the scenario that you're looking for here. So you have to think, what are they talking about? So your dependent is the number of trucks washed, and the independent quantity is the time it takes to wash those trucks. So the number of trucks washed depends upon the time it takes to wash the trucks. In this activity, you are given 3 scenarios and 3 graphs. You have to match these. And so look at scenario number 1. Darby begins the test with a possible total points of 94 points. She loses 3 points for every question she answers incorrectly. Number 2, Heidi has 16 pennies in her piggy bank initially. She doubles the number of pennies in her piggy bank each day for 8 days. Number 3, it costs $5 for Laura to enter the school's Falls Festival and 50 cents for each ticket purchase. So you're going to fill out the graph number 1. Which scenario goes with graph number 1? Which scenario goes with graph number 2? Which scenario goes with graph number 3? Pause me while you look at it and figure it out. Here are the answers to that activity you just completed. So graph number 1 goes with real world scenario number 1. Notice that this is a linear graph. It is decreasing. You're starting with 94 points and you're going down by 3 points every single problem that you miss. So it is graph number 1 matches scenario number 1. Scenario number 2 will match graph number 2. It is an exponential graph, and you're starting at with just 16 pennies, and you're doubling it every day for 8 days, and so it will be going up quite a bit real fast. And this is increasing in graph number 2. Graph number 3 goes with scenario number 1. You start with $5 in your account and you are going to purchase tickets for 50 cents each time. So it is a steady increase and it is linear, and you're increasing from left to right on the graph. In this rural scenario, you're going to match the independent and dependent quantities. Farah drove to the lake. She was there for about an hour. Then Farah drove back to the house. The graph represents this scenario. What is the dependent quantity? So find your answer down below and pause me while you look for it. The dependent quantity in this rural scenario is distance from Farah's house in miles. Looking at the graph to the right, you see the x-axis, which is your horizontal axis, is your independent quantity, and you're looking at time. Your measurement is in minutes. And then the y-axis, which is your vertical axis, and it is also your dependent axis, or your dependent quantity, is talking about distance, and you're measuring it in miles. Now looking at the graph, you're starting at 0, and the line increases from left to right. So this is where she's driving to the lake. She stays at the lake, so you see a horizontal lake for a number of minutes, and then she leaves the lake and heads back to her house. So the line goes back down, which is decreasing. So it matches this real world scenario. Now in this scenario, you have a lawyer's fees at $180 per hour for his services. Identify the independent and dependent quantities and see if you can come up and write a function for this scenario. On this slide, you will see the independent quantity that you're looking for is hours of service. Dependent is talking about the lawyer's fee, and the function, you would write it as f of x equals 180x. So this lawyer is getting paid $180 per hour, and so 180 is your dependent, and your x would be the number of hours that you would be working. You could also write it as y equals 180x. In this scenario, you have the admission fee at a carnival is $9, and each ride costs $1.75. Identify the dependent and independent quantities and write a function for it. Pause me while you do this. The independent quantity would be your number of rides that you've ridden. Your dependent quantity would be the total cost. And the function for this, and it doesn't matter if you write it as f of x, g of x, or h of x, but here it's written as g of x. And so it's $1.75 per ride. So you have a $1.75 X, and you start out with the admission fee of $9. This would be your function for it. In this scenario, you have Stan, who is a local delivery driver. He's paid $4 per mile driven plus a daily amount of $75. So identify the independent and dependent quantities and write the function for this. Pause me while you do that. In this scenario, you see the keyword per. So look at the phrase $4 per mile. Your independent is miles driven and your dependent is total pay. So you're looking at cost per mile, and you see the function S of X equals 4X plus 75. So it's 4 stands for the amount that you're paying per mile. The X will stand for how many miles that you drive, and you have to put down a down payment of $75. And you see the word plus in this scenario, plus $75. Here's another scenario. Georgia, a florist, charges $15 per flower bundle plus $20 delivery charge. Identify the independent and dependent quantities and write the function, and put me on pause while you do this. So in this scenario, you see the keyword per right here. So you have the phrase 15 per flower bundle. So $15 is your total pay right here. And then your flower bundle is your independent, and you see the plus $20 right here. So if you were to write a function, you're going to simply put 15. Think about the per as being an X right here, and then the word plus, and you're going to put a plus over the word plus. And when you write your function, it's going to be J of X equals 15X plus 20. Now, so far you have identified independent and dependent quantities. How can key characteristics of a graph tell a story? Think about it and pause me while you think. Think about the old saying, a picture's worth 1,000 words. Well, a graph is the same way. It is a visual image. So you could read about it, such as if a person's operating a business, they can read about or talk about a pace of runners running to break a world record, or you can just simply look at the picture. And a picture, as I said, is worth 1,000 words at times. So graphs do relay the information in a very visual way. However, you need to be very careful because not all points on a graph will make sense. However, on some graphs, all the points do make sense. So you have to just look at the graph in the situation and think to yourself, do these points make sense? Now we have been talking about dependent and independent quantities right here. So the dependent quantity will always change. It is the one that is being forced to change by the independent quantity. It depends upon the independent quantity. However, the independent quantity is the one who will force the other to change. It can stand alone. The independent quantity will always force the dependent quantity to change. Independent quantity can stand alone. In this scenario, David rode his bike to the park, which was 1.5 miles from his house. After staying at the park for a few minutes, he then continued to ride his bike to the grocery store. On number 1, I want you to identify the independent and dependent quantities. Number 2, I want you to circle the graph that matches the scenario. Label the axis with the appropriate quantity and unit of measurement. Pause me while you do this. On this last slide, you will see that I've gone ahead and labeled everything for David's bike ride. You see the independent quantity. You're looking at time and you're measuring it in minutes, and that is your x-axis, your horizontal axis. Your y-axis, which is your vertical axis, is your dependent quantity that we're looking at. We're looking at distance, and our unit of measurement is in miles. So this is how your graph should look. So check your graph to see if it matches this graph.